The user is then faced with determining the most significant lameness problem based on the number of strikes assigned to each limb, how much greater the lameness values are above threshold in each limb, and known compensatory lameness patterns. Compensatory lameness patterns are more clearly measured with the inertial sensors than seen because of increased sampling frequency over the naked human eye. A compensatory lameness is an apparent but false lameness caused in the opposite half of the body because of weight shifting to unload the primarily affected limb. Compensatory lameness patterns follow the law of sides, which has two parts. And not all horses show compensatory lameness patterns, but some horses show quite strong compensatory patterns. The first part of the law of sides states that primary hind limb lameness will cause compensatory, false, ipsilateral forelimb lameness. During weight bearing in the diagonal, including the lame hind limb, weight is shifted forward, causing the head to move further downward. This makes it appear that the horse does not move the head down on the forelimb ipsilateral to the lame hind limb. Often the primary hind limb lameness may be relatively mild and difficult to see, with a more apparent and easier to see false compensatory forelimb lameness. Here's a perfect example. This horse appears like it has a left forelimb lameness. If you look very carefully, however, you can see that it also has a left hind limb lameness. And this left forelimb lameness is actually false and compensatory. This horse had stifle lameness, arthritis of the stifle, and elimination of the stifle lameness eliminated this compensatory head movement. Here is a typical lameness locator report showing left hind limb lameness and left forelimb lameness. Presented with this pair of left lameness or ipsilateral lameness, the most logical conclusion would be that this horse has a primary left hind limb lameness and that this left forelimb lameness could be compensatory. The second part of the law of sides states that primary forelimb lameness will cause compensatory hind limb lameness, that is, impact on the same side and push off on the opposite side. During weight bearing in the diagonal, including the primarily lamed forelimb, weight is shifted back, causing the pelvis to move further downward during contralateral hind limb stance. This makes it appear that the horse comes down less on the ipsilateral hind limb. Additionally, when forced to trot in a straight line, the horse will push off the ipsilateral hind limb in the normal diagonal more than the contralateral hind limb in the lame diagonal. This makes it appear that the horse has contralateral push-off type hind limb lameness. Because the amplitude of the primary forelimb lameness must be quite significant before the compensatory movements are actually seen, mistaking compensatory hind limb lameness for primary forelimb lameness in real life is uncommon. However, the patterns in the hind limb lameness plot can be helpful in determining forelimb lameness, especially in cases of misbehaving horses when head movement is quite erratic. In primary left forelimb lameness, the green rays point down on the left and red rays up on the right, in a direction that would rotate the subplot around in a counterclockwise to the left direction. In primary right forelimb lameness, the green rays point down on the right and red rays up on the left, rotating the subplot in a clockwise to the right direction. Note that the compensatory hind limb pattern can be either ipsilateral impact or contralateral push-off, or both. This makes it particularly difficult to interpret a trial that indicates ipsilateral fore and hind impact lameness. It is this type of situation where history, results of other clinical tests, and the skill and experience of the veterinarian are important.